Hi there, this is Srikanth Dasari. So in this lesson, we are going to learn about how to program a single linked list in C. Okay, so we will look how to create two functions here. One is for creating a linked list, another for just displaying the contents of the linked list. Okay, so here I am in my Visual C++ 2005 Express version, which I use for the which I used for the previous lessons also. So I have created here a project with the name single linked list 1, and it consists nothing but single linked list.c5 here. Okay, so let me go to full screen here. So I'm adding all the basic stuff like header files. Okay, so hash include studio.h, choreo.h, and now. Uh, So first we need to define, so before starting writing the program for a linked list, first we need to define our structure or structure for our node. Okay, so linked list is nothing but a collection of nodes. So each node again consists of two parts. One is a data part and address part. So address part of the node consists the address of the next node. Okay, so it is something like a collection of nodes. Okay, so first let me define the structure for node. Struct node. Okay, struct node, as we said, it consists of two parts. First one is data part. So data part I'm taking an integer, and it consists of address part, which is also known as a pointer to the structure itself, or else self-referential structure, which is the correct word we need to use here. Okay, so the reason I'm taking it this structure as a global thing, because we need not pass the node each and every time. Okay, so that's the reason I'm taking it outside the main, such that it is accessible to all the functions which we define outside the main, and we can call subsequently in the main for our usage purpose. So next I'm going to take define another node, struct node head. Okay, so head or start, whatever you wanted, you can take the pointer. The head is a special pointer of type node, which always consists the address of the starting node. Okay, so head always, so head pointer holds the address, holds the address of the starting node, holds the address of the starting node of the linked list. Okay, so head pointer holds the address of the starting node of the linked list. Okay, so next we have uh, so let's write the main function first. Later then we can define our functions. Okay, so inside the main I'm just taking a variable choice. So just to have the choice for I'm building a menu here. Let's say, let's put it in do while loop here. Okay, so do, first option is going to be create linked list or create list or whatever you wanted. So create linked list is that going to be the first option. So next one, second option is going to be the display linked list. Display linked list. Let's have some room here. Create linked list. Let's put some room in between. Create linked list. Okay, display linked list. And third option is going to be just quite normal exit here. Okay, so here in our program we are performing only two operations here. The one is creating of a linked list or displaying of a linked list, and exiting the linked list. Okay, so three options. Let's have a printf statement just to say that enter your choice or something like that. Enter your choice and scanf. Let's put a scanf here in order to grab the choice from the keyboard, and grab the choice from the keyboard. Okay, so we are done with our do loop here. Do not do, just with the menu driven thing here. Okay, so next let us build the switch case. So all these things are very quite common in any data structures program. Okay, so do, let's close the while loop here. Do while loop, since we are taking a do while loop, ch not equal to 3, the loop will continuously run until the time such that the user would not enter the third option here. Okay, since the third option is to just to come out of the execution. Okay, so let's write the cases, dummy cases here. Later on, we'll call the appropriate functions in that cases here. Okay, so the first case, nothing. Haven't defined any function here. I'm just putting a break statement, and in the same way, case 2, I'm putting the break statement once again, and case 3. Case 3 is going to be so exit function. So case 3 is going to be exit function, and let's have a break for that too, and let's have a default. Let's say printf. Let's put a message in the default statement. Wrong entry. Wrong entry. Okay, or else you can have try again also, something like that. Wrong entry. Try again. Okay. So let's put a break for default also, it's although not necessary. Okay, so we're done with our case statement also main. So if you run this program until now, if everything goes well, just displays already we have a error here. It says that exit exit function need to be included in a header file here, which is stdlib.h. So stdlib.h. Okay, so nothing, we haven't done anything excited here. We have just built a menu for our linked list. It just displays the menu, create linked list. You select the option 1, nothing happens because we haven't called any appropriate function there. And if you select the option 2, nothing happens. If you select option 3, it comes out of the execution. Okay, so this is just, we have built a menus. Now let's write the functions here. Okay, so in order to avoid writing prototypes, I'm just putting the function above the main itself. Okay, so not after the main, above the main here. Okay, so let's say the first function is create a list here. Okay, so create list or create linked list, whatever you wanted. I'm just, let's say, create linked list only to avoid the confusion. So this function, the sole purpose of this function is to just to create the linked list and keep on adding the elements into the nodes into the linked list. Okay, so let's see how we'll do that. So before that, let's do one more thing here. So let's say head is equal to null. Okay, so which is very essential thing, the very first thing. Okay, so since head, if we say head is equal to null, which means that let's run it until now, nothing happens. Excited. Again, we have an error here. Create linked list. Since we have taken it, it returns a null. Okay, later we will do that. Okay, head is equal to null, which is very initialized, shows that tells that the list is empty. In order to check whether the linked list is empty, so we need to put the head value to null by putting that initially null to null value. So if it's null, then automatically the linked list is empty. Okay, so we have learned that the head is a pointer which points to the address of the starting node of the linked list. So if the head itself is null, which means that our linked list, there are no nodes in our linked list and our linked list is empty. Okay, so first in our linked list function, let's take two important pointers here. Okay, so struct node star new node, struct node star new node, and star 10. Okay, so let's take two pointers here. So after that, let's allocate some memory to the node. Let's say new node is equal to, so new node is equal to malloc, or before that we need to cast this with the node type struct node star, since we are using a pointer to the type node here. So malloc size of struct node. Okay, so this is going to be our creation of node statement. Okay, so this statement used to creation, I'm putting a comment here, creation of a new node, excuse me, creation of a new node in the linked list. Okay, so you have just created a new node here. So immediately after that, as soon as we have created a new node, so we need to add some data. So into the data part or item, we need to add some data into the data part of our linked list. Okay, so linked list is a collection of, as we have learned that linked list is a collection of nodes, and each node consists of two parts. One is the data part, which is very essential to store the information and the next node, the next part is the address part, which contains the address of the next node. Okay, so let's put a statement here. Let's enter the data into the linked list. Okay, so just put a statement here. Just put a statement scanf percentage d ampersand new node of data. So new node of data. Okay, so ampersand new node of data. Okay, so if we have just entered, we have created a node and we have entered the data part, and that for the new node, for the address part of the new node is going to be, so new node of next equal to null. Okay, so new node of next is equal to null. Okay, so now before placing this node in our linked list, first we need to check whether the linked list is either empty or not. Okay, so whether whether the linked list is empty. So there is no case of point, then our newly created node will become the head here. Okay, so if the linked list is empty, whatever the node we have created, then that itself is the only one node we have, and that should be, then the head pointer should point to that node. Okay, so if you say like this, that head is equal to null, you say something like this. Okay, so then what means this is head is equal to new node. Okay, so head is equal to new node and return 1. So you need to come out of the function. You need to come out of the function. That's the reason you are using return 1. Okay, so that's the reason we have put here int here. Okay, so just to come out of the function, if there is only one node, and that automatically we are making the head to point to that node, and we are coming out of the function. Okay, so in the else part, it's a critical part here. So in the else part, we are making use of our temporary pointer, which we have created for the type node here. Okay, so that will consist of the address of head. That will consist of address of head, and we need to run the loop until the temp next part. Now the address part is not equal to null. Okay, so we need to run the loop until the address part of the temporary node, or which we have assigned the head address we have assigned in the temporary node. So now head and temp both point to the starting node of the linked list here, starting node of the linked list. So until that is not null, which means that the ending node of the linked list will always have the null address, null in the address part of the that particular node here. Okay, so until that node, what we need to do is temp is equal to temp next. Okay, so we are just moving the temporary part to that until that thing. And now what we are doing is coming out of the while loop here. So what we are meant to do is the new node, or so now in the temp next part, so we need to assign our newly created node. Okay, such that the link establishes. Okay, so we are using the while loop to run until the last node in the data structure, or the last node in the linked list, and then we are storing the address of the new node in the next part of the that particular ending part of our already existing linked list. Okay, so now we are done with our coding with create linked list part here. Okay, so let's write the function for display also. Let's say void display. So here we don't display anything, or we don't return anything. So for that reason, I'm using a void function here. Okay. So before that, let's say, so node star temp. Okay, it's node star temp. So temp is equal to head. So all these things are normal procedures. Temp is equal to head. So if head not equal to null, if head not equal to null, so if head not equal to null, only then we need to proceed. Okay, so that's, which means that the list is not empty. So you can make use of a for loop here. Okay, or else you can directly use this statement inside the for loop also. Here we are making use of the for loop. So for, so temp is equal to head, and temp not equal to null, temp until temp is not null, temp is equal to temp next. Okay, so we are sliding until the ending thing of our ending part of our node, and with the help of the printf statement here, and with the help of the printf statement, we are just outputting all the contents of the node. Okay, so let's say temp of data. Okay, so temp of data. That's it. Okay. So done with our else. In the else part, you can have a simple message if printf /n/t the list is empty. Okay, so which means that if there are the head itself is null, then you can directly say that the list is empty. Okay. So now coming to our, we have done with our function definitions. So coming back to our case function here. So case one deals with the creation of the linked list. So we need, let's call the appropriate linked list function here. So let's say let's call the linked list create linked list function. So create linked list function, and the case two, and in the case two, we let's call the display function. Let's in the case two, let's call the display function. So now let's run the entire program. Everything goes well. We have again two errors here. Create linked list. Create. We have missed e here in the definition. Silly mistake. So run the program until now. If everything goes well, yes, it's turned out. Let me increase the font size here. It's a console 36 and so on and so forth. So now if you select one, it asks us for the data part to enter into the linked list. I have entered one. Again, let's keep on adding the 5 different elements in the linked list. So 5. Let's make use of a display here now. It just displays all the 5 elements here. Okay. So if you observe in the output, we have just entered so 5 elements, and it displayed the all the 5 elements which are stored in the linked list. Okay. So if you select 3, it comes out of the program. So the main advantage of linked list using a linked list rather than a static array, because linked list acts as a dynamic array, and here you have an opportunity to keep on adding the elements. So you need not know the fixed size. You need not fix a huge size like taking an array. And if you if you don't make use of that complete size of the array, the rest of the space is getting wasted here. So in order to avoid all those drawbacks, we have linked list concept here. So you have so if you run the program once again, so let's keep on adding some how many elements. So whatever the depending upon your requirement, you can keep on adding the elements. There is no size limit. There is no size limit of adding the elements here. Okay. So if you take display, it just displays all the elements. I hope something is missing here. Just a second. Interestingly. So nothing has missed here. Okay. So display, we have entered totally 9 elements here. So 9 got displayed here. Okay. So in that way, so let's put a /t instead of in the display function. Let's put a /t instead of /n. So let's run the program now. 3, 4, 5 display. Okay. So here is our display elements here. Okay. So to summarize once again the program. So first we have defined a node for our node, which is a structured node, which consists of both the data part and the address part here. Okay. So later that we have defined two functions. One is for creating the linked list, and another for displaying the contents of the linked list. In the main, we have done the same thing until now. What we have done for all our previous data structure programs, we have built a menu depending upon how many operations you are handling there. So here we are handling only two operations. Okay, so creating and displaying the linked list. We have built a menu program, and in the case appropriate function is being called here. If we come back to the CreateList function, so first, the very first time we have created a node with this syntax here, and we are trying to enter putting some data into the node, whatever you wanted, and then we have assigned the next part of the newly created node to null. And then we have checking whether the whether the linked list or whether the linked list is empty or not. If the head is null, then it's empty. Okay. So then the very first node, of the linked list is going to be head. So that's what we have done here. Or else we need to traverse until the ending of the linked list using a while loop here. And at the last part node, we are just assigning the newly created node, and we are which means literally we are appending the newly created node to the last node of the currently existing linked list. Okay, so if you come to the display function here, we haven't done anything excited much here. We have taken a temporary pointer, and with the help of the for loop, we are traversing the linked list from the beginning to the ending until it's not null. So null in the linked list shows that the exiting the last we are about to encounter at the end of the linked list. Okay, so or else you don't know where you need to end when you're writing programs using a linked list. Okay, so if the program or the loop encounters null, which means that that is the ending of the linked list here. Okay, so making use of this for loop, we are traversing the entire linked list from the beginning to the ending, and we are just displaying the contents of the linked list here. Okay, so in the else part, if the very first node, if the head is null, then obviously the list will be empty. Okay, so if you run the program and if you select the display function without inputting any nodes or inputting any data into the linked list, since initially the linked list is empty, the head shows that the head is equal to null. So here you get this message here. Okay, the list is empty. Okay, so only if exists at least one element in the linked list, then only you are able to display. Okay, so if you select the two now, it displayed the item one here. Okay, so this is the basic stuff about linked list. So hope this tutorial helped you. So if it helped you, really give it a thumbs up and put your valuable feedback in the form of comments and YouTube. So see you in the next lesson. Goodbye.